Hello, everyone. Good morning, good evening, and good afternoon based on your destination time. I'm Dr. Johnson. I'll be today talking about SkyPro Guide software, the module 6, and this is our last module where I'll be talking about Sandbox. So my laptop is here, so I'll be just looking sometimes on the screen. I'll share my screen just a minute. Yes, so this is our SkyPro Guides plan software. Again, I will repeat few things since this is our last module. This is the real guide software exclusively made for Brilliant users. So you can use only Brilliant implants. And to get this, you have to contact your country representative, and then we will give you a license for testing, trying, or you want to plan your implants, and then you can guide it for your cases. So this is SkyPro Guide plan software for Brilliant users. The origin is from Real Guide. In previous module, module 5, we have done about different varieties of surgical guide, including stackable guide, bone reduction guide, and everything. And today's session is about Sandbox. It can be called as entirely a new software or a different software altogether. The options it has is too huge, too many options, and it has a lot of advanced tools. You can customize any kind of STL format in that, and you can make your own STL format. We don't have enough time to get into all the options, so I will just share only the crucial options which are there. And also to clarify, in all the last 5 modules, we have used Sandbox multiple times, including to create stackable guide. So I will not get into what is already taught, but I will be repeating something which makes sense and useful for us. So getting into the software. So we shall take one case from here. I will open a case which we have designed last time. Okay. So we have crossed all these stages, and then if you see this logo which says Sandbox, click on that. I will just use this STL file just as a reference. I'm not doing anything on this as such, but I'll use this as a reference. So if you see the first few options, first it says create. So this is to create something new, create some new STL file. And on the already existing files also. These tools are used to create some new STL file. And this is to process whatever STL files are created here, or to process the new STL files with the old existing STL files, like what you have segmented the bone. This is segmented bone, means the volume bone from CBCT file is converted to STL file. So these STL file or even surgical guides, like this surgical guide, these STL or something which you create new can be processed by using this STL file. For example, joining them, cutting them, or reducing them, subtract them. All this can be processed by this. So this is the main difference between here and here. And the previous STL files in the previous section, whatever you designed STL files are here. So if this is clear, we'll go to geometric primitives. I click here. And if you see here, this is add. We have various shapes here to select from. For example, I'll start with cylinder, and cylinder looks something like this. I can reduce the radius or increase the radius here. I can reduce the height or decrease the height of this thing. This can also be managed after placing the STL file on the screen. And this is something nice. So this is 100% round. And if you reduce this, if you see me reducing, you can see the change in the design here. So you see if I go on reducing, then it becomes triangle. So you can increase the number of sizes and make whatever shape you want. For now, I'll keep it as a cylinder. Then click OK. And if you see normal to surface, this is what is selected, normal to surface. So as I go, it'll be stuck to surface. Like this, it will just placing on the surface. If I say click from view, it will be exactly parallel to my viewpoint. If you see, it doesn't change anything. So if I click here like this, it will join something like this. If I click here, it will be something like this. So for now, I'll click normal to surface. So I do right click to position it to somewhere it's okay. And then here I can press custom transformation, and then I get this option to transform. If I just select this round dot and pull it out, it'll increase from all the sides, the size of the cylinder. Let's imagine I want this, but now I want to increase from behind. Then I press Control and just stretch it. Only this part increases. You see? And if I press click from here, only this increases, this side, the buckle side. If I click here, only this side increases. So I'll just keep it cylinder. When I increase this, it becomes elliptical. So then I increase here. Now, when I want to finalize it, it's in a state where I can still transform. When I want to finalize it, go to the STL file and give a right click. And then this is finalized. It's finalized in position. If ever you want to change anything again, just click on the, give a left click, and again you can go for transformation. So I will give a right click. Now this STL file is created. I want to do something on top of it. So I will go again to add. Maybe I will change a little shape of this. We'll use something like this and then click again. Okay. And now I want to place it. You see, I'm able to place anywhere, not just one place. I can place it anywhere, but I want exactly center. So I click flat face to center and then I click here. Now there is no chance either it'll place on this center or on this center somewhere. But now I want it here. I click on this. I go to custom transformation. I increase this length only. And now I'm satisfied. I give a right click. On top of this, I will use another shape. For examples, I can go for sphere. I can manage the radius here or on the tool by itself. So again, I can either select face to center and then I click somewhere or so this option circle to fit, either I can fix on this circle here, the lower cylinder, and then I can make this transparent, go to custom transformation. I can pull this, select this bigger arrow to pull it out. And then I can increase the radius of it, pull it a little down. Yeah, then right click. And then again, make it opaque. So you have something like smooth transformation from here to here. I can add the same measurement. I can just duplicate using this one. The same circle of the same radius will be duplicated. And then I click circle fit and I can either click here or face center also will work here. So then I can go to custom transformation and again manage it where you want to place it. For now, this is nothing related to dentistry, but you will use it some point of your cases to make your own connectors or to make your guide stronger, or in some situations I have used it, but to explain all the tools I have to make something new for you to understand. Okay, so now once I have created all these things and you can see all the STL files what I have created new are here 1, 2, 3, 4, and then I can switch off the mandible. Here we see merge all visible primitives. So if you see here, we have 4 primitives, and when I say merge them all, then you get 5th primitive. So I'll just switch off this and then I will switch off one by one. So now you have merged part as one. So we can go here and rename it as STL1 file what I generated. Okay, so this is our merged part. I'll create one more part which will be separate from this and I'll be using it in next, as I said, processing stage. So click here. Maybe I'll take a cone with rounded cone. Okay, and I will place it face to center and custom transformation. Yeah, I can create a rocket. So anyways, So I just keep this STL file here so that I can show you how it works in the next processing stage. Okay, so this is how geometric primitives work. You also have option with tubes and the donut shapes. And so many other tools options are available. So you can use it based on your convenience. And then once you are finally okay with this, we just can go end tool. So we have some object like this. Okay, I will just create one more object for the next option. Sphere. I can even change the color of sphere change, maybe blue. Next is custom bar. This we use regularly for making guide much more stronger. In we add material on the guide or to support the tongue for the guide. We use this bar creation. So here this is circle. So you click on few points and this creates your bar. Okay, so here are a few points. Now this is in the center. If I click on this and click on free, it becomes based on wherever you place the point, and you can increase, decrease, you can raise it or make it lower. But if you click on center, it takes the center of this circle, this cylinder. So this is how you can create bar, and we can have different shape. This is circle, we can have square, or we can make our own ellipse, or we can make our own custom shape. I'll click on customs. For example, I add arc, I click 2 points, and then I make it circle. Then I say add polyline and close it. So now I have some cylinder kind of thing. Then apply it. Free. So if you see, we have kind of a flat surface followed by circle here. We can even rotate this thing. For example, now this is facing upwards, so I can rotate it to down. I can make the flat surface go down. So there are many options, and snap is every point you select will be converted into hard constraints is that every point you selected will be into it will not be smooth transaction, but it will be just bends. This is hard constraints. And closed bar is now the bar is closed. It's joining together. There is no free end. It's all joined together. And there is one more option called when you go onto the particular point, click on that and edit cross section. So here I want ellipse, and maybe I want to change the diameter a little, and then apply. So it works in the center or free. It's confusing. I will make new bar. I mixed up too many options, then it's confusing. So circle, make few points, and then at this particular point, edit cross section. I select ellipse, change, apply. And you see this particular area, the shape is changed. I'll show once again ellipse. This time I increase the diameter, apply. So you see this. This is how it works. You can change particular points. And once you are okay with this, and then I say create bar. On top of this bar, I can say new bar, circle, apply. I can make it look like a bag or something. So I use this like this versions for surgical guide to keep the tongue out of it. Something like this. I will show it on surgical guide if possible. Yeah, let's imagine we want to keep the tongue away from the implant area. So new bar, and I do it like this and create bar. So this helps me to keep the tongue away from the surgical site. So that's how you create a bar. And then model from scan. So I'll show a model from scan, how to do a model. So you have your STL file. If you want to cut something, you can edit the STL files and cut these things. Editing model I have done in module 2. So I will not explain this right now. We can go to module 2 and not module 2, module, yeah, 2. Yeah, exactly. Yeah. So next step, you can adjust the height, and then if you want it to be shell, then you have to click on shell. If you want it to be a solid model, then you have to switch it off. Now we'll keep it as shell. And what should be the thickness of the shell is around 3.7 mm. I have kept it. And then this is for number of drain channels. You can reduce it. You can reduce the height of the drain. Then next step. Now we can add text here. Sandbox. And then pen tool. So we have a model with a shell of thickness of 3.7 and with the label and the 3D printing drain holes. Then we can finalize it. Again, go to Sandbox. It will come out of Sandbox because we have finalized it. So this is one option, and then I'll go to next option is volume from contact surface. We will go to, yeah, we'll go to the bone. Okay, so this is for creating graft kind of materials. So I have spline selected, so I can click by points, and then I can keep the spacer. This volume offset is 10 micron spacer. What is the thickness of the maximum thickness is 2.54 or 3 maybe. And then perimeter thickness is the thickness of the margin. So I can keep it little, and this one 3 smoothness, and then I can say generate volume. So it will create a volume for you. Then you can 3D print it. And also you can you can define the pattern. Click on define pattern. And you have such patterns here. It's square. Also you can select circle, and what should be the pattern size, or the border should be protected from the pattern, and then again generate volume. So you have a pattern volume, and click next. You can still modify them by cutting area, or you can just create a screw hole size. You can create multiple screw holes. And you can also see in the DICOM file how it works. Then end tool. So that's how you create volume from surface. This is for block out. So next is next now coming to processes, whatever we have designed till now. So going to Boolean operations first, we will object A is what you want to merge or subtract. For example, primitive 5, yeah. I want to merge this to STL1, the product which I made, and it's in position. So now it is merged to, I can use subtract from or remove any intersections between them like that. So now I'll do subtract from. Offset is 0. If you observe, I'll make this. Now I say subtract from and create the result into new object. And anything extra comes up, just remove them. So I click apply. So if you see, it has subtracted from this place, and now we can use this as some tool or something. And if I create offset of like 15 microns, then I say apply, it creates additional gap. If you see, there is additional gap between these two. So offset is used for that. So if, to be more clear, yeah, you see, it creates so much of offset here, the gap between these two. And if you don't want to subtract, you want to merge both of them, you can also merge them here. So from object A, merge to object B, and I click apply, it'll be merged. So that's how Boolean operations work. I will keep it subtract. Apply. Yeah, I'll keep it subtracted and end tool. So we use this a lot in, again, in surgical guide for making stackable. I will switch off this and then go to volume splitting. Next option, volume splitting. This I have explained in surgical guide already, but here I will explain again. So we have a sphere, and then I add some slots. And then I give a shift plus click on that, bring it down and increase the height. Okay, let's imagine this is a place. So this slot will be used for subtracting or splitting a sphere into two parts. One is this and other one is this. So now this is with a flat base. I can add some spikes into this to keep it more stronger. So I can add spikes here. I can manage the spikes distances here, too many spikes or less spikes, and also the height, how deep you want or how shallow you want it, and the radius of the spikes, depending on case to case. And then we go next and we say subtract the slot. So you see it's cut into two parts. If I go end tool, now you have two slots. One is this, and the other one is this slot. So you get, that's how you get volume splitting, used again for making surgical guides. Now, if after surgical guide is made, now you need to connect these two so that it can be placed well with each other in the patient's mouth. So I have to add connectors. So I go to add connectors, go to add, I select some connector. Okay. And then I click and reduce the size of it, position it well, still more reduce the size of it. So position one part in the blue and one in the orange or pink, whatever it is. So this is a female and this is a male. So we have to continue placing the next connector in the same position, in the same alignment, because three males cannot get into the female perfectly if they're not aligned right. So the next option is to just duplicate whatever the last connector was designed. So I click on duplicate and keep it the same Z axis and just position it wherever it is supposed to be positioned. Duplicate it, the last one, position it, and done. Three connectors are done. Then next step. So it's asking what is a base object and what is a removal object. So this big sphere is a base object and small one is removable object. So I just say apply. So now we have base object and removal object with connectors. So if you see base object is with female, it will stay fixed, and the upper removable object is with male. So when I'm done, it's end tool. So edit can add connectors. Edit object, we have already done it in multiple modules. The next is edit STL as volume. So in segmentation, we have done volume CBCT file to STL file. The same thing in reverse. When you make edit STL as volume, it'll make the STL as a CBCT file. And object placement is when your arches are not rightly placed, upper and lower is not placed rightly, then you can use this object placement with like what I have explained here, these options. You can readjust these options. So add text is adding the name on top of it. So it's not much here. So yeah, this is Sandbox. This is our last session of for this particular version. Real Guide has come up with version 6. Right now we are testing it for Brilliant. And once we are confident about it, then we will launch Typro Guide 6 version, which also has web version for itself, where you can plan and design surgical guide online on the web version. You don't need to download the software. And also it has few AI features where it'll plan implants automatically and all, but yes, we have to test it. After testing, we'll launch it, and also we'll have one more webinar on the new features of Real Guide 6 or SkyPro Guide 6. So if you have questions, I'm here. Otherwise, thanks a lot for joining me through all the 6 sessions. It was nice to hold this webinar. Hope you learned a lot and you will use it in your regular practices. Thanks a lot. Thank you.